Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 20, questions 64 to 67. And in this unit, it provided us with a cascade of reactions required to produce a blood clot. I guess the key to solving these questions is by employing pattern recognition. So that's the important thing here. So you've got to take note of the symbols presented in this section, titled Key, and pay close attention to the direction of the symbols. So if we take a look at question 64, it says which of the following is a precursor for factor 5? So if we take a look at the figure 1 and go straight to factor 5, we can see that what's happening is that factor 5 is clearly a cofactor for factor 10A. So once these factors, they activate the conversion of prothrombin to thrombin, so a negative feedback loop is set up, as we can see here, facilitating active protein C mediated inhibition of factor 5 activity. So the precursor for factor 5 is just it's not provided. So all we know from the options is that active protein C, no, that's just negative feedback. It's not the precursor. Factor 10A, no, factor 5 is a cofactor for 10A. So, sorry, that's wrong. That's wrong. Thrombin, if we take a look at the image here, thrombin is, well, factor 5 is involved in helping factor 10A in converting prothrombin to thrombin, but thrombin is definitely not a precursor for factor 5, so it is incorrect. Therefore, neither A, B, or C are correct because it's not providing the stimulus what the precursor for factor 5 is. So that's the answer for 64. So if we move on now to question 65, the question is asking, which of the following is most likely the role of factor 8? So if we take a look at the figure 1 in the stimulus again, if we take a look at factor 8, we can see clearly it's a cofactor for factor 9A in helping convert factor 10 to factor 10A. So if we take a look at the options available, the only option that fits that description is going to be A. So it enhances the activity of factor 9A. So you can clearly see that because it's a cofactor, it helps in the conversion of factor 10 to factor 10A. So therefore, the answer has to be A. And I think the trick with this question was just wrapping your head around the Roman numerals and not getting confused with what they're telling us. And pretty much understanding what a cofactor is and what conversion and activation are. So if we now move on to question 66, it's asking us, from when the wound surface contact begins, which one of the following is likely to first occur after the longest period of time? Now, they've worded this in a very funny way. When they say what is likely to first occur after the longest period of time, it just means what's the last thing to happen. So we're looking for what is the last thing to happen from the list of, so conversion of fibrinogen to fibrin clot, effective negative feedback, effective positive feedback, and activation of protein C. So if we can actually list those in order of when they occur, so the first thing that's going to happen from this list is we're going to get positive feedback. So that's going to be, so C is going to be the first thing that happens. If we take a look at the list, the next thing that's going to happen is we're going to obviously convert fibrinogen to fibrin clot. So that's going to be the second thing that's going to happen. So if we take a look then on the list, what we have left, so then we're going to activate protein C, and then we're going to activate negative feedback. So in this question, what we're looking for is this. So it's, I think because they're worded that funny, that's what will throw off a lot of students. So obviously 66, the answer is going to be B, because it's the last one that occurs. But remember, we're trying to make a blood clot here. If we're trying to make a blood clot, we're going to do everything we can to make a blood clot. That means that positive feedback is going to be pretty high. So that's what's going to be upregulated the most, the positive feedback. So we're going to be converting lots of fibrinogen to fibrin clot. We're going to have lots of positive feedback. And then what happens is, after the longest period of time, the clot, so the blood has stopped bleeding from the area because the clot is big enough. So now we have to obviously remove this clot. So in order to stop building this clot, we have to activate protein C and then negative feedback to rewind the process of the clotting because we've stopped the blood from bleeding. So that's how we'd approach question 66. And it kind of leads in nicely to the last question. So question 67, which asks, in biological regulatory mechanisms, positive feedback what? So it's important to note that positive feedback aims to increase the change or output. So what that does is it makes something happen more quickly. Whereas negative feedback tries to reduce the change or output. So that's obviously going to reduce or bring the system back to a stable state. So it's important to note if you're going to have a negative feedback, it has to come back to parity. So there has to be an equilibrium in, say, biological systems. So you can't have negative feedback without having positive feedback. Because if you just have negative feedback, for example, in blood clots, if we just had positive feedback, we'd just be building a clot for no apparent reason. Because if there's no reason to build a clot, why are we doing it? So we have to bring it back to parity. So that's why we have the negative feedback to stop building the clot. So it's the same instance here. If we take a look at the options from A to D, so it says A is more useful mechanism than negative feedback. That's not true. Depending on context, negative or positive feedback can be more useful. So A is incorrect. B usually occurs in the absence of negative feedback. That is not true. Remember, we have to bring the system back to equilibrium. So if we're going to have positive feedback, we have to have negative feedback. So that's incorrect. C is unlikely to occur in the absence of negative feedback. That's correct. So clearly you can see 67 has to be C because it's like a yin and yang. They have to occur with each other. And D says is likely to occur in all the same pathways as negative feedback. Now, the reason why that's incorrect is because you could have downstream, say 5 pathways downstream, an effect because of the negative feedback in a different pathway. So you might have a positive feedback in that system or negative feedback in that system, but they're not related because something happened 10 steps beforehand in the pathway down or upstream. So that's why D is incorrect, because they can happen in different pathways. So with this sort of unit, it's mainly about reading the figure properly, recognizing patterns, and reading the key properly. So if you have any more questions about this unit, you can post them in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.